Yeah, it would.
Yay.
Okay. This is the class that probably a recording would not work for. We'll try it. Why? Because you guys are giggling. And that is out. Okay. All right. So we have two theorems. Haley. We have two theorems to look at today. We have so far 3 ways to prove triangles congruent: side, 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 angle, side, and angle, side, angle. We're going to add 2 more ways to that. So we are going to have angle, angle, side, and hypotenuse leg. These 3 right here that we already have are postulates. The 2 we're going to add on the end here are theorems that we're going to prove today. Colton, could you please put the comments in? Very entertaining, I will read it, but no.
I was going to get recording.
Yep. Okay. So the 2 theorems, theorem 4.4. Sorry, theorem 4.3 is the first one.
Why are you recording this?
Then the lesson will be online, and whoever would not be here will be able to access it. It's kind of a good idea. Yeah, I'm recording right now.
Where is it?
Well, it's actually, I don't know that Mark has built the YouTube site yet, but it's going to be on YouTube.
I bet you just have it up if you
We're going to be a video.
Yeah.
They're like videoing us right now?
No, it's not a video. I'm screen recording. See how that is? And the sound goes to that mic right there.
Oh, there's a mic.
There's a microphone. Yep.
I should sit right below it.
Just say something.
Thank you.
Okay. So can we continue now?
Yes.
All right.
Yes, ma'am.
What we have with angle, angle, side theorem, which theorem 4.3, is 2 angles and a non-included side of one triangle are congruent to 2 angles and a non-included side of another triangle. Then the triangles will be congruent.
Stop with this looking.
Oh, maybe. Yeah. Somebody over this.
Is that one non?
It is non-included.
Right.
So what we have in our diagram then is in our 2 triangles, I'll clone this triangle. We have 2 angles, maybe these 2 angles, and a non-included side that are congruent. A non-included side would be which side here? I have 2 options, don't I? It could either be this side here, or it could be that side there. With its 2 angles and a non-included side, I have 2 options. I can either walk around the triangle going counterclockwise and get angle, angle, side, or I can walk around the triangle clockwise and get angle, angle, side, right? Either way, I have angle, angle, side. Now, with triangle, we'll label these triangles. And Haley and Nick, I want you paying attention and not talking to each other. So, triangle ABC and triangle DEF. Our given is going to be that the parts that are marked are congruent here. So our given is marked on the diagram. What we are going to prove is that triangle ABC is congruent to triangle DEF. Now, what we're going to do to help us get there is again use that corollary that we've worked with a few other times, and recently we worked with it at least 2 other times. That if we know that 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles must be congruent. Which would mean that angle C and angle F would have to be congruent. They're congruent because A and B are congruent to D and E. And the sum of the angles is 180. So if 2 angles of one triangle congruent to 2 angles of another, the third angles will have to be congruent. That's corollary 1, I think, of theorem 311. We are. But right now we're just brainstorming. So now, if I show that angle C is congruent to angle F, can I prove that the triangles are congruent by one of these 3 theorems? Yes. Angle, side, angle, yes. So that's the direction we're going to go. Where I'll start is angle C is congruent to angle F. No, I'm going to do paragraph. Mostly from here on out, I'll do paragraph. I'll see if Mark can put it on tonight. Okay? Okay, I agree. You're right, and I needed that one more.
I just tried noticing people.
No, that's all right. We're up here. Okay. Now, if you could gather your attention again, we're ready to get started here. Angle C is congruent to angle F. We could say by corollary 1 of theorem 311. Now this would mean that the triangle ABC is congruent to triangle DEF by angle, side, angle. End of proof.
Is that corollary 1 or just corollary?
It's corollary 1 of theorem 311. Now, the next theorem, theorem 4.4, is a theorem that I have struggled with every time I have tried to prove it for the past 13 years. That's how long I've been teaching geometry. How long I've had to prove this next theorem.
That's honestly really cheap.
It is. It's kind of a difficult proof. Yeah. So please, as I go through the proof of the next theorem, help me out, because every single time I've done it, I've struggled with it. Okay, so I need your attention and I need your input. I need both of those in order for me to be able to get this done. Okay? So, and by the way, are proofs always going to be easy? No, they're hard for me too. Proofs are not easy. There's something that you struggle with until you figure out how to do it, and then you can do it, right? So that's one reason why it's good that I have a couple theorems as we go through this book that I will struggle with. This is one of them. Okay, so theorem 4.4. Theorem 4.4 is called the hypotenuse leg theorem. What type of triangle has a hypotenuse in the leg? A right triangle. So this theorem is only good for right triangles. So hypotenuse leg theorem. Or in other words, HL. So this theorem says if a hypotenuse and a leg of one right triangle are congruent to a hypotenuse and a leg of another right triangle, then the two triangles are congruent.
Ashley Holmes and Catherine Powell come to the office.
So now we have a right triangle. And I'll clone this right triangle. What we know about these two right triangles is that we have a hypotenuse and a leg that are congruent in those two right triangles. Now what we are going to do is we're going to have a point P that's formed. Let's go ahead and label the triangles A, B, C, and D, E, F. And I am going to extend side DF from D going to the left. And we'll put a point P on this side that makes DP congruent to AC. And then we're going to draw the segment PE. Thank you. I already practiced on this proof once with last week's class, so I think I can make it through it. Yes, I did. I missed it. I started drawing the wrong piece congruent and had to erase and start completely over. Okay. So, like I said, this is a hard proof for me to do. Now, what we know is, and let's go ahead and mark our given and what we want to prove. But what we know is that because this is a right angle, then angle PDE is also a right angle. Okay, we're going to know that. Our given information is the parts marked on the diagram. Are congruent. What we want to prove here is that triangle ABC is congruent to triangle DEF. Now, what I know is I have some triangles that are congruent right now. Because of how I marked this point P so that PD is equal and linked to AC, what are the triangles that are congruent right now? Right. We have triangles ABC congruent to triangle, and I have to have same corresponding order, so it has to be D, E, P. By what? Side angle side, yes, side angle side. Now, since those triangles are congruent, all the corresponding parts are congruent. So, the parts I'm going to use of these two triangles that are congruent are PE is congruent to BC, and angle P is congruent to angle C. I'm going to use both of those in this proof. So, PE is congruent to BC. And angle P is congruent to angle C. Why are those pieces congruent? Why are those parts of these triangles congruent? Because the triangles are congruent, right? And their corresponding parts? EPC. Yes. So because corresponding parts of congruent triangles are congruent. Now, because BC was marked congruent to EF already, by transitive property, PE has to be congruent to EF. If PE is congruent to EF, what type of triangle is PEF? It's isosceles, isn't it? So PE is congruent to EF, which makes triangle PEF isosceles. What do we know about isosceles triangles? Two sides are equal, that's definition. What do we know by theorem 4.1 about isosceles triangles? The opposite angles, yes. So angle P must be congruent to angle F. And that's theorem 4.1. What I can do now is actually another transitive property or substitution. Because P is congruent to F and P is congruent to C, C must be congruent to F. Now take a look at triangle ABC and triangle DEF. Nick, you're still talking. Okay. Take a look at triangle ABC and triangle DEF. Are they congruent by one of these four reasons? We get to use angle side now because we have proved it. So if we, it is angle, angle, side. We have angle C, angle A, and side AB, or else angle A, angle C, and side BC. It doesn't matter which way we do it. We have those same pieces on triangle DEF. Because we don't have the side in between the two angles here. We could probably get there, but we don't. Okay? What we have is, I'll mark it with blue, angle, angle, and side. Angle, angle, and side. In order for it to be angle, side, angle, it would have to be the angle, the side, and the angle. We don't have this side. No, we're talking about DEF. That's what we're trying to prove. So we had to go through this whole rigmarole with triangle DEP to get there. Yes, no, they will not make you do a proof like this. Okay? So we can end this up now. We can say that triangle ABC must be congruent to triangle DEF by angle, angle, side. All right. You did it. Thank you very much for helping me out.
Yeah.
I will go down and just try to put everything on one page here. So we now have 5 ways to prove triangles congruent. We have side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. The question now is, let's look at what we do have, and let's talk about what we do not have. So we have side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. What do we not have? Angle, angle, angle,
Side, side angle.
and side, side, angle. Now let's talk about why these two do not work. Yes, angle, angle, angle is a similar triangle, not necessarily congruent. Let me show you why. Here we have parallel sides. If I draw a couple of transversals forming 2 triangles, we have the same angles, don't we? But they are not congruent. So, angle, angle, angle does not work. You cannot have angle, angle,
Side, side.
Right. Yes, totally. But angle, 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 Haley, does not show triangles congruent. Okay, so there we can't use it. Okay. Yes.
Oh my God.
Okay. Now, if you could all gather attention here again. The other one you mentioned, side, side angle, we cannot use either, and we're going to talk about why not. So if I am looking at this nice little sketch here, what I have is a triangle, and you can see I can move this side around, but it always keeps the same length, right? Fact is, that side is always the length of this segment. See how that works?
Joe, Raina, come to the office.
Okay, so this segment gives me the length of that side there. Now, next thing, and need your attention. This segment right here gives me the length of this side. Same idea. So if I move this side around, I get that happen. Okay?
You messed
So whatever segment this is the length of that side. Which means I have a triangle. When this actually forms a triangle, this circle has to intersect this bottom side in order for that to form a triangle, right? Those two have to intersect in order for there to be a triangle formed. So now, I need to make this side longer in order for that circle to intersect that side. So when I make it longer, then we have a triangle that has
Bring
three,
it upward, come to the apple.
that has a side, and this specific angle. But the question is, can I form another triangle with that same side angle? What I will do is move this around until it goes right there, and then I have another triangle with the same side, and angle. So, does it show that triangles are congruent when they have the same side, then angle? No, it does not. So, side, angle is another one that does not work. Now, here's something else I want you to look at. Okay? I want you to be quiet. Could you be quiet? Okay. Now, side angle is a way that does not work. What would this spell if we went around the other direction?
ASS.
Which is something that you would not want to write on your paper, right?
Oh, I was right.
Okay. So now, Nick, I need your attention, because when you do not give me your attention, there are other people that are not giving me your attention. Give me their attention. There I go. Okay? So now, let me try again. The only options that do not work are the one that you would not want to spell on your paper. Okay? And angle. Those are the ones that do not work. Rebecca, you didn't have something to add. You did not have something to add? Okay. Wow. I'm working hard to try to keep your attention at this point. So, could you give me your attention? Please! Okay. When you look at hypotenuse leg,
She's gonna deck you so hard.
doesn't it look like side angle?
Yeah.
No.
But it's not.
The only time that you can use something that looks like side angle is when it's a right triangle. And then it's hypotenuse leg. Yes.